right, say something into the microphone.
You want to hear a joke?
Yeah. Tell me the joke.
Knock.
Who's there?
Interrupting chicken.
Interrupting chicken. All right.
That is so funny.
All right. We are asked to figure out whether the journey from point A to point B in each of these cases represents this vector. Remember, a vector looks a little bit like an ordered pair, like on the coordinate plane, like a location, but it's not. It's usually we use these like square brackets, or sometimes you'll see these types of brackets, and what it refers to is a movement. So the first, normally where the x-coordinate would go, is our change in x. So how far is the x-coordinate changing as we travel from point A to point B? And the second part is how much is the y-coordinate changing as we go from point A to point B. And the notation for these, by the way, is delta x, delta y. That's the little triangle is delta. So if you see that notation, that's what it means. Change in x, change in y. So anywhere where our x-coordinate going from one point to the next goes forward 5 units, and the y-coordinate goes up 3, then that's going to represent that vector. So let's take a look at what happens here. Oh, by the way, there's one other little thing we need here, which is change equals end minus start. Change equals end minus start. So when you're taking a journey, the change is always the end minus the start. So here, if we're traveling from this point to this point, our change in x will equal end 2 minus start negative 3, which is 5. And our change in y will equal end 8 minus 5, which is 3. So this is the vector 5, 3. Check. Next door here, end minus start. Our change in x is 6 minus 3, which is 3. You can see we're off to some trouble already. And our change in y is equal to end minus start, 12 minus 7, which is 5. So this is the vector 3, 5, not 5, 3. Down here, our change in x is equal to end minus start. So negative 1 minus negative 6, which is 5. Looks promising. And our change in y is end minus start, 7 minus 4, equals 3. And so this is the vector 5, 3. Check. And here, our change in x, end minus start, 1 minus 6, is negative 5. And our change in y, delta y, is negative 1 minus 2, which is negative 3. So this represents the vector negative 5, negative 3. Notice, by the way, so this one is not 5, 3, but notice it's negative 5, negative 3. So actually, if we were to go the other direction, then we would have the vector 5, 3. Right? But the direction matters. It's not just how far, it's what direction we're going. So again, if you want to figure out whether a certain journey from one point to the next represents that vector, we just calculate our change in x and our change in y by calculating the end coordinate minus the starting coordinate. And then, well, we see if the change matches what we're looking for. In this case, it was 5, 3.